Hello all. In our last video we had started with module 5 in which we discussed about cables subjected to concentrated loads, and in today's lecture let's see cables subjected to uniformly distributed load. So for that, consider a cable of length L and it is supported at points A and B, which are at a horizontal distance of small l, and they are at the same level. That is, suppose they are at the same level. So the length of the cable, we have assumed it as L, and the supports A and B are at a distance small l apart, and A and B, they are at the same level. And let the cable be subjected to uniformly distributed load W per unit horizontal length. So the cable, it is subjected to a UDL of W per meter over its horizontal length. So from the symmetry we can see this. So this is like a simply supported beam in which a UDL is acting, and we know in that case the reactions RA and RB or VA and VB will be equal to WL by 2. So here also we have VA is equal to VB equal to W into L by 2. So we found out the reactions, vertical reactions VA and VB. Now we'll find out what is the horizontal thrust exerted at the supports. For that, consider the central point of the cable. Consider the central point of the cable and assume that the central dip at this particular point is small h. Okay. Now, taking moment about that point, say let it be C. Taking moment about that point C, we have, and considering the left side of portion C, what are the forces you have? H into, this is a point C that we are considering. So H into small h minus the reaction VA into L by 2, that is minus WL by 2 into L by 2. Now the UDL, W into L by 2 into center L by 4. And we know cable being a flexible member, it does not resist any shear force or bending moment. Hence we can equate the moment about that point is equal to 0. So equating that equal to 0, the value of H, we'll get it as WL square by 8H, where H, capital H, is a horizontal thrust exerted at the supports, W is a UDL acting on the cable, L is a distance between the support, and H is a central dip occurring to the cable. Okay, so we found out the vertical reactions and the horizontal thrust exerted at the cables. Next we'll see what is the maximum and minimum tensile stress exerted on the cable. And we have discussed in the last class that in cable only tensile forces will be exerted. And we are interested to know what are the maximum tensile force exerted and what is the minimum tensile force exerted. To find it out, we know the tensile stress at any point T can be taken as the square root of vertical reaction plus horizontal reactions. So at any point the tension exerted on the cable is equal to root of V square plus H square, root of vertical forces and sum of squares of vertical forces and horizontal forces. Now maximum tensile force exerted on the cable will be dependent on the value of the maximum vertical force and the maximum horizontal force exerted. The horizontal force is the horizontal thrust exerted on the cable, and that we have already found it as WL square by 8H. And the maximum vertical force, where it will be exerted? The maximum vertical force, definitely it will be exerted at the support. That is, the vertical reactions that we have found out is the maximum vertical force exerted on the cable. So we have already found it as V max, which is equal to WL by 2. So substituting the value of maximum value of vertical force, we'll get the maximum tensile stress exerted on the tensile force exerted on the cable. So T max, we can take it as WL by 2 the whole square, which is equal to V max plus H, WL square by 8H the whole square. So we'll get, this is not V max, this is T max itself. So T max is equal to WL by 2 into root of 1 plus L square by 16H square. So that is the maximum tensile force exerted on the cable. Now, what will be the minimum tensile force exerted? Minimum tensile force exerted will be corresponding to the minimum vertical force exerted on the cable. Where we'll have the minimum vertical force? Definitely it will be at the center. How do we know that? We have learned the bending moment diagram and shear force diagram of a simply supported beam, in which we have something like the shear force diagram where the shear force is 0 at the center. So V minimum will be 0 at the center, right? So the minimum tensile stress will be, tensile force will be exerted at the center, and its value will be corresponding to 0 plus h square the whole raised to 1 by 2, or T minimum is h. Right. So we found out what is the maximum tensile force exerted and what will be the minimum tensile force exerted. Maximum will be at the support and minimum will be at the center. And the vertical force at any point, we can find it out using the equation V equal to T into sine theta. Okay, so we found the reactions, we found the horizontal thrust exerted at the supports, we found out what is the maximum tensile force exerted and what will be the minimum tensile force exerted on the cable. Next, we'll see once a load is applied, once a UDL is applied on the cable, what will be the shape of the cable. In case of cable subjected to point load, we had assumed that the cable consists of individual straight line segments in between the supports. Right, that's how we did the analysis of cables as subjected to concentrated loads. We treated the length in between the point loads as straight lines. But in case of UDL, what will be the shape of the cable? That is what we are going to find out next. Now, to find the shape of the cable, consider the portion on the left side of section XX. So we are considering a point XX at a distance x from end A. Let the angle exerted by the cable with respect to horizontal be theta. Right. Now, if we take sum of horizontal forces equal to 0, what will be the value? A tension T is exerted on the cable, and we have assumed that it is inclined at an angle theta. So, the horizontal force is equal to T cos theta, and its value has to be equal to h in order to have an equilibrium condition. So we can write sigma h equal to 0 means T cos theta is equal to h. Right. Similarly, if we take the sum of vertical forces equal to 0, what are the vertical forces acting? The vertical reaction VA is acting here in the upward direction, and a UDL W into X is acting in the downward direction, and also the vertical component of T, that is T sine theta, is acting in the vertical direction. So if we take sigma V equal to 0, we can write it as T sine theta is equal to VA minus W into X. The value of VA, we already found it as WL by 2. So WL by 2 minus W into X. If we consider this as our equation 1 and this as our equation number 2, dividing those two equations, we get tan theta is equal to T sin theta divided by T cos theta is equal to VA minus W into X divided by H. Or we can write tan theta is equal to W by 2 minus W into X into 1 divided by H. What is tan theta? Tan theta is normally taken as the slope, or we can replace tan theta as dy by dx. So dy by dx is equal to WL by 2 minus W into x into 1 by h. Integrating this equation, integral of dy by dx, we know it is y. So y is equal to WL by 2 into x minus Wx square by 2 into 1 by h. Simplifying this, Wx into L minus x by 2h. Now what is the value of h? That we have already seen it as WL square by 8h. So substituting the value of W in this equation, we can simplify this as y is equal to 4h into x into L minus x by L square, where h is a central dip at the cable of the cable, x is the distance from the left support where we want to find out the deflection, y, L is the distance between the two supports, right? And this equation, we are familiar with this equation in our mathematics portions. It is an equation for parabola. So we came to the conclusion that the shape of the cable is a parabola. Okay, the shape of the cable is a parabola. So this is a parabola satisfying the equation y equal to 4h into x into L minus x by L square, where you have to know what are the individual values. Y is a dip at any distance, say x, from this end. Okay, or you can write it here. This is the value of y at a distance x from end A, and h is a central dip or the maximum dip occurring to the cable. So 4hx into L minus x by L square. This is an important derivation which is normally asked in the university question. How can we prove that the shape of a cable is parabola in case of a uniformly distributed load? Okay, so you have to learn this derivation. Now, the length of the cable, this you can learn it as such. Length of the cable, that is this length. Length of the cable is L is equal to small l plus 8h square by 3l, where L is the distance between the supports. And the slope of the cable, theta, it is the, or how can we write? We know h is equal to T max into cos theta, or theta is equal to cos inverse h by T max. Okay, so you have to know the formula for parabola, you have to know the formula for length of the cable, you have to know the slope of the cable. Okay, horizontal thrust, vertical reaction, etc. all is needed for the doing the problem. So let's see some problems on this area. A suspension cable has a span of 160 meter and a central dip of 16 meter. It carries a UDL of 5 kN per meter over the entire span. Calculate the maximum and minimum tension in the cable, length of the cable, and the deflection at 100 meter from the left support. Okay, so in university question paper, often only statement will be given, no diagram will be given to you, hence you should be familiar to draw the diagram from the question. So here you have given a suspension cable of length of span 160 meter, that is the value of small l is equal to 160 meter. Central dip, that means small h is equal to 16 meter. W 5 kilonewton per meter. And you are asked to calculate the deflection at 100 meter from the left support, that is x is equal to 100 meter. So based on this question, we can draw this diagram. So we have the central dip at 16 meter, length 160 meter, subjected to UDL. The end supports assumed to be in the same level. Okay, so we first wrote down what are the given factors, and we'll start doing the problem by first finding out the reactions and the horizontal thrust. So what was equations for reactions Ra and Rb? We can write it as WL by 2. W is given to you, L is given to you as 5 and 160. Substituting those values, the value of Ra and Rb is found out as 400 kilonewton. Now, horizontal thrust, what was the formula? WL square by 8H. So 5 into 160 square by 8 into 16, you found the value of H. Now, we are asked to find out the maximum and minimum tension exerted on the cable. The formula we know for finding out T max is equal to root of V max square plus H square. V max we know it is a reaction, so WL by 2 the whole square plus WL square by 8H the whole square. The values we have already found it as 400 and 1000. Substituting those values, find out the value of maximum tension exerted on the cable. Now, what is the minimum tension? We have already discussed that it occurs at the center where V is equal to 0. So, root of H square or equal to H. So, T minimum is equal to H, which is equal to WL square by 8H. And we get it as 1000 kilonewton. Okay, next what is asked to find out? You are asked to find out deflection at a distance 100 meter from the left support. Deflection means what? The value of y. For that we have already learned the equation for parabola. Y is equal to 4h into x by l square into l minus x, where h is the central dip, x is the distance from the left support where we need to find out the deflection, l is the distance between the support. So all those values are given to you. Substituting those values, you will get the deflection at a distance 100 meter from the left end as 15 meter. Next, what is you are asked to find out? You are asked to find out the length of the cable. So length of the cable formula we know, L is equal to L plus 8h square by 3 into L. All the values are given to you of the length of the cable. Okay. So the problems coming in this module is almost straightforward questions. There is no much complications over here, but the only difficulty is that you should know the formulas. If you know the formula, it is just the direct application of them. Okay, so the only difficulty that you face in learning this module will be learning the formulas. So in coming lectures, more equations will be there. So write down in a paper the consolidated list of formulas while you are learning for university exam. Revise it again and again, then only the formulas will get registered in your brain. If you know the formula, sure 15 marks or 10 marks will be guaranteed to you. Okay. So in the next question, a light cable 18 meter long is supported at two ends at the same level, which are 16 meter apart. The cable is subjected to UDL of 1 kilonewton per meter over its entire span. Determine the reactions developed at the supports, maximum and minimum tension in the cable, and inclination of the cable with the support. So based on the question, what will be the figure? So you draw the figure. We have the two ends which are 16 meters. So small length is equal to 15 meter. So the length between the supports, small l, is given as 16 meter, and the load W is given as 1 kilonewton per meter. Light cable 18 meter long. That means what? Small l is also given to you as 16 meter. You are asked to find out the reactions of the support as well as the maximum and minimum tension in the cable and inclination of the cable with respect to the horizontal. So the reactions, what is the value of reactions? Ra equal to Rb equal to, we know it is equal to WL by 2. The value of W is 1. Length between the support, it is given as 16 meter. So 16 by 2, 8 kilonewton. Now, so we found out the reactions developed at the supports. Now the length L, we know equation is L plus 8h square divided by 3 into L. The value of capital L is given to you, small l is given to you. you need to find out the central tip H. So substituting those values, solve for H. You will get it as H is equal to 3.46 meter. Okay, once a value small h is obtained, you can find out the horizontal reaction. H is equal to WL square by 8 into H. Solving that, the value of H is equal to 9.24 kilonewton. Now these values are necessary in order to find out the maximum and minimum tension occurring to the cable. So what is T max? T max is equal to root of V max square plus H square. The value of V max is 8 kilonewton plus the value of H is 9.24. Substituting it, you will get it as 12.22 kilonewton. Now the minimum, T minimum is H itself, which is equal to 9.24 kilonewton. Okay, so you found the reactions of the support, the maximum and minimum tension in the cable. Now what is the formula for inclination theta? We know it is equal to cos inverse H by T max. All the values we know. So solving that, the inclination theta is equal to 40.87 degrees Celsius. Okay, clear? So one last question. A suspension cable has a span of 100 meter, carries a UDL of 10 kilonewton per meter over the entire span. If the deflection of the cable at a distance of 30 meter from left end is 3 meter, find the central dip of the cable, length of the cable, horizontal thrust and deflection at every 1/4 point. So cable is given to you having a span of 100 meter, that is small l is equal to 100 meter. It carries a UDL W of 10 kilonewton per meter. Now, if the deflection of the cable at a distance of 30 meter from the left end is 3 meter, that is what y is equal. What is that value? Y is equal to 3 meter for x is equal to 30 meter. You're asked to find out the central dip small h, length of the cable capital L, horizontal thrust capital H and deflection at every 1/4 of the point. So total length is 100 meter. So every 1/4 means for every 25 meter you have to find out what is the deflection. Okay, so we draw the diagram based on the question given to you. We wrote down what are the given values. Okay, now from the given data, that is deflection is equal to 3 meter at 30 meter from the left end, you can solve for what is unknown in this case. Y is equal to 4hx by L square into L minus x. Value of L is given to you, Y is given to you, X is also given to you. So the only unknown is H. H is a central dip. So solving that, the value of H, you'll get it as 3.57 meter. So the central dip or the central deflection of the cable is equal to 3.57. Okay. Now the length of the cable, we know the formula L is equal to L by 8h square by 3L. The values of L, H and all is known. So substituting capital L, you'll get it as 100.33 meter. So length of the cable is also found out. Now horizontal thrust WL square by 8h. Substituting the value, you will get it as 3501.4 kilonewton. Now the deflection at every 1/4 of the point, that is where that is for x is equal to 25. So next is 50 and again 75. Okay, for x equal to 25, what will be the value? Substituting 4 into 3.57 into x as 25, find out y. So you'll get it as 2.667. Since it is a symmetrical condition, the deflection occurring at 25 meter from the left end will be the same as the deflection occurring at 25 meter from the right end. Or you can assume that for x equal to 25 and x equal to 75, the value of y is the same as 2.677. Now x equal to 50 means what? It is the central portion, and we have already found out this deflection at the central portion as small h. Okay, so we have already found out the deflection at all the points required. Okay, so that's about cable subjected to UDL. Hope it is clear to you. I again remind you that the formulas you have to learn, then only this module will be easier for you. Okay, thank you.